Today we are going to look at heat and heat transfer. Our essential question is, what is heat and how is it transferred from one place to another? Before we look at heat, we need to know a little bit of vocabulary. Remember, kinetic energy is the energy of an object because of motion. The word kinetic comes from the Greek word for motion. Our first topic question is, what is temperature? Temperature measures the average kinetic energy of the particles of an object or substance. It's like a speedometer for how fast particles are moving. There are three main temperature scales: Fahrenheit, which is used in the United States, Celsius, which is used for science, and Kelvin, which is an absolute temperature used in science. To go from Fahrenheit to Celsius, or vice versa, takes a little bit of math, but to go between Celsius and Kelvin is really easy. Just add 273 to Celsius to get Kelvin. So 100 degrees Celsius becomes 373 Kelvin. Similarly, to go from Kelvin to Celsius, we'll subtract 273. So 310 Kelvin becomes 37 degrees Celsius. Go ahead and try to fill out the room temperature on your own. By the way, water freezes at 273 Kelvin, or 0 degrees Celsius. Remember, the size of an object or the amount of a substance does not affect the temperature. These pots both have very different sizes, but they both have the same temperature, 100 degrees Celsius, or the boiling point of water. However, this little tiny match will have a temperature of 700 degrees Celsius. Now, despite the temperature of the two pots being the same, the bigger pot actually does have more energy overall. Can you guess why? It's because the big pot has more molecules. Remember, temperature is a measure of the average amount of energy of the particles inside of a substance has. So, for any two things at the same temperature, the one with the bigger amount of molecules is going to have more energy. Now, let's look at our second topic. What is heat? Heat is the flow of energy from a warmer place to a cooler place due to a difference in temperature. This is why you feel cold when you're sick and your body's running a fever, because the outside air feels relatively cooler than usual. This also means that when you feel a block of ice and it's cold, you're not actually feeling the cold. What's happening is the energy in your hand is being transferred to the ice cube. So what you're feeling is actually the absence of the heat that was there before. You feel cold whenever thermal energy leaves. One last thing that's important to remember is that an object or system does not have heat. Heat's the flow of thermal energy due to a temperature difference. It's transferring the heat over. It's a process, not an object. Now, let's consider topic question 3. What is thermal equilibrium? Thermal equilibrium is what happens when heat flows from a higher temperature object to a lower temperature object until the two objects have an equal temperature. If you look at the two blocks on the left, the red one is 100 degrees Celsius, so it's got more thermal energy, and the cooler block is 0 degrees Celsius. It has less thermal energy. So the heat is going to flow from the hotter object to the colder object until the two reach equilibrium, which means they have the same temperature. In this case, because both blocks are the same size and they have the same number of particles, the temperature is going to end up halfway between the two. Here's an example. Heat will continue to flow out of this kettle until the kettle and the air around it reach the same temperature, thermal equilibrium. Because there's a lot more air than there is hot water in the kettle, then the temperature it's going to settle on is going to be pretty much room temperature. We will learn more about how heat is transferred in the next video.